Um, as long as the same dialogue doesn't pop up again and block my screen. I think we're okay though. Oh, I'm so sorry about that. Despite having been traveling for a little while, it's very much I'm not at my desk at home, so I don't have two screens and a mouse that I can be familiar with. So everything's overlaid on one screen. So I'm going to do my best to juggle. Anyhow, so thank you so much, Ari, for the invitation to come and speak. And like you said, unfortunately, the meeting is a bit late when I'm UK time, but it was pretty cool to be able to be over in the States. A shame not to see people in person, but I'm glad to be able to present this evening. And also, it's great to be in New York again. It feels like it's been way too long. And hopefully next time I'll see some people face to face. So a bit about myself. I guess I've been a software engineer for about 20 years. I've been around various communities and technologies. Open source development has been a bit of a passion on and off. And I've been involved in other graphical projects like the Enlightenment and their EFL libraries and other open source communities such as Maven, amongst others. And that background has been quite relevant for the latest project. Through years of developing in mobile apps, I left that and came back to see that desktop software hadn't progressed. And I thought this is something that we could really do well to learn. If we could build graphical applications that just worked on any platform, you know, and looked good, had the same UX and care, it would be a real compelling thing to do. And so I thought, right, well, let's go ahead and look in that area. And I came up with very little that seemed like it fit the bill. And so I thought, well, we should build something. And I needed a programming language, and it seemed like Go was a really great fit. So I've been a Go developer for 2 weeks longer than the Fyne project existed, which is just over 4 years now. And today I wanted to share a little bit about my journey through realizing that Go is just a fantastic language for building graphical applications, which is obviously not what it was designed for, but it seems to be a pretty great fit. My work at the moment is full-time on the Fyne toolkit through community aspect, building out functionality, and also from a business point of view, we're looking at what tools would work alongside it and how we can better support a sustainable future for the platform. And so for my business, it's called Fyne Labs, and I wish I had a title like Ari said, you know, to be told what your title is, but those of us working there haven't really figured that out yet. So startup phase, and we're just going to muddling through, which is probably where I really enjoy the most. Some people have called me a serial CTO to this stage, so don't know if that's a good or a bad thing. Anyhow, sorry, without further ado, let me introduce, I suppose, some of the background for anybody who's not familiar with graphical applications and the fun that it has been to work with them over the last 30 years. The screenshot there is of one of the very early ones out of one of the Palo Alto research centers. And despite being more than 50 years old, there's probably a number of familiar elements to it. If you've developed an app, at least not one that's specifically focused on mobile, you've probably seen that it's based in C or something that's derived from it. And that's, well, it carries its own legacy. You have to think about memory management and all sorts of things that kind of just get in the way when you're trying to build your application. And thread handling as well. Graphic brings the complication of, well, everything has to be done on the thread that the CPU wants to communicate with. And it seems like that should be a thing of the past. And most of the toolkits that this is built to, well, that have been built to solve these problems were built so long ago that web services weren't a thing. And GTK and Qt, their heritage goes back more than 25, 30 odd years. So you can see how there's a lot of stuff that wasn't there. In fact, strings were all byte arrays back then, and fun of forgetting null termination and things like that. You might notice there that all of those things should be just dealt with now. If you've been developing on Go, you'll notice that all of that's solved. So why hasn't that been then taken into the UI? Well, part of that is because modern technologies have come along and just bound their API to old systems. But that brings a lot of legacy along. Your Go code might look good, but it's going to have to understand the complications of memory management and thread handling that come along with it, because it's not really solved the problem. And that leads to difficulties with learning it, because you're not learning one language, you're learning multiple, and the constraints also that come along with it. And some of these toolkits, they're massive and fantastic. They have a lot of functionality, but with that has the challenge of learning everything that they bring. They've evolved a lot along the way, and that may not be best adapted to modern systems. And also, they could be pretty large. In fact, I tried to get started with Qt development, and the download was about 7 gig, required 40 gig of space on my hard drive before I could run Hello World. So not the most friendly way to get started. Sorry, my clicker has just stopped working. I will abandon my clicker. It's not working at all. Anyway, so coming into the world of Go, I probably abused the term object there, but we're going to be in a place that is not purely flat files with no namespace like C is providing for a lot of the existing toolkits. In fact, we can, if widget is defined as a basic interface, we can clearly pass around lots of instances and understand what functionality exists on a widget. And Go is going to provide the opportunity to extend these objects. So we could add functionality in to this generic type or type that's fulfilling an interface. And we could also define new widgets, concrete types that implement this interface, by composing existing widgets as well, which makes it quite flexible to bring custom elements quickly together. And any library that's looking to work in this space, because with Go, you can basically just import a package and you've got a whole bunch of functionality, almost irrespective of who or where it was developed. So that's pretty great to get a standard set of widgets into any application. And also, because of this ability to publish and share code, developers are free to pick up whatever widgets have been created by the community, which is just a fantastic way to be able to build on all of the work that other people are doing as well. So that's, you know, heading in the direction of why I think Go is solving these problems quite well. But also, we've got native app on any platform. Clearly, we are going to be able to write our code once and run it on anything. Now, people have promised that in the past for applications. The JVM was one of them. Qt and GTK have theoretically solved this problem, but all of those require some kind of runtime setup. And you know, we don't think that really is the right way. If you're running Go code, you just compile it and put it onto the device. We're managing to use the latest techniques and technologies of the language, whether it's test-driven development or other functions, the fuzzing that's coming in and all sorts of things. This is all going to be available to a toolkit that's designed for the language. And as we've seen from Tour, the Go Tour, sorry, I was about to say the old URL, I can't remember the new one, but it's super simple to get started with Go. So we could make it super simple to get started building a graphical app. And because we're better understanding UX and design principles now, we could make it really easy to make it look good as standard. So small teams of engineers don't have to hire a designer to meet a reasonable bar. And we can promote good engineering principles, test-driven development or unit testing as a whole, the linting and the formatting that comes with Go. It just makes things that are put together quickly much more polished, and users get a good, oh, I'm doing it the right way experience, rather than piling a bunch of code into a file and then trying to tear it apart later. So I think these are all really great reasons why Go is going to be a good fit for building graphical applications. There's actually really great examples of people who've done that before. I'm going to say, you know, Fyne is a great one because I've been working on it for so long. Geo, of a similar age, is working if you're looking at the immediate mode type. I'm not going to get into immediate versus retained, although I can answer questions if folk are really interested. Shiny, one of the projects put together by the Go team, that's not really well maintained right now, but it's still out there. Those make for great native toolkits for the language. And we have bindings to existing technologies if you want to try them out. There's various different projects actually for GTK and Qt bindings, and NK is for Nuclear, another immediate mode toolkit. Perhaps better suited to games, but it's out there and you can use it. You might experience some of these strange language bridging challenges that I described before. Of course, there is web, hybrid approaches where you've got HTML, CSS, JavaScript bundled into your application. I don't feel that's quite so exciting, although there's good knowledge of how these technologies work. Hiring is perhaps a little bit easier. The user experience and performance is just not quite as good. So I don't think it's the right way to push new application development. You can check out Awesome Go. They have a GUI section which lists a lot more than that if you would like to see the full extent of what's available. And if you want to know more about my comparison of many of these technologies, you can check out the book that's pictured there. I wrote it a few years ago, so it doesn't include Go, which hadn't been announced at the time. And it was certainly much earlier in my journey with Go, so I might have to make a few apologies if quality is not there. But it's an interesting read if comparing these technologies to what you're interested in. However, today, being a Fyne person, I'm definitely going to talk about Fyne and show you just how easy it is to build a good-looking application using these technologies that is just quick to get started and runs on anything. A few prerequisites that you need to have, at least Go 1.14 is required. We're looking at newer ones, but we like to keep the version requirement as low as possible so we can support the most devices. In fact, that means that a Fyne application is going to work on your old abandoned iOS 32-bit device if you're interested. You will need a C compiler. It's just part of addressing graphics efficiently. So that can lead to some complications with cross-compiling, but there's great tooling out there, including Fyne Cross, which uses Docker to hide all of the complexity if that's a worry. These are provided by the various packages there. There's documentation on our website and many others about how to set that up if you don't happen to have these tools installed already. If you're interested in trying out, making sure your stack is working or seeing what's possible before you code something out, you can check Fyne demo. I guess that's the slightly older format of Go install. But either way, that's the URL. It's all in the Fyne.io domain, and we have that Fyne demo command available. And if you go get that, it's just going to install onto your system in the path like any other Go application, and you can run that and see what is possible. You'll see a screen much like that. Maybe in light mode if that's the standard for your computer, because it's going to try and match colors and font sizes and so forth to seem natural. It's also available on the Google Play Store if you have an Android device and you want to see how that works on mobile. But let's start a little bit of coding. Here again, if you haven't already, you'll need to start a project, init it with your module, and go get the latest V2 of the Fyne project. We moved on from version 1, I think early last year, a chance to improve the API and set up for a better future. And V2 is going to be good for a couple of years. We're going to edit a little UI.go file, and it's going to look like this. Simple hello world application. This is basically the smallest Fyne app. We're importing two packages, the app package, which does all of the setup and auto discovery of your platform, and the widget package, which obviously is providing widgets. So in our code, we just create a new application instance, which is configured for the current device at runtime. We create a new window. We give it a title in case the environment titles windows. And then we set the content to a new label widget that says Hello Fyne. And then we show and run the application. So that's showing a window and running the application. A great shortcut if you just have one window to show. And we go run that directory or that file. And it's going to say Hello Fyne. And there you go, the light theme matching the light operating system configuration. Nothing much of a surprise there, but that was pretty easy. So let's look a little bit more what we can do before I get into the functionality available. We can actually support test-driven development of your graphical user interface. Now, this is one thing that I think has been lacking from many modern tooling in the graphical space. In fact, some people have said it's just not possible or it's too hard. So we've provided a test package that you can see used here, and we can use that to simulate typing, mouse interactions, and we can make standard asserts against widget state. In fact, there's more helpers in the test package that also allow you to capture the window, compare it to a golden image, or render it to an XML file if you want to compare the every little detail about the state as well. And we're just going to run those tests using the same Go test framework. So Go test, and it's going to run all of those. You'll not see a single window popping up because we're using in-memory drivers to run all of these. It's the same code running, but it doesn't have to populate a window on screen. So you don't lose control of your mouse and keyboard like other frameworks like Selenium might do for your website. So you've got your app, you've tested it, but you want to package it because a binary on your file system is not quite enough for a graphical application. People expect an icon that they can tap on. So to do this, we have another command called Fyne, and that's just going to be a helper tool on your path alongside the standard Go tools that will do a lot of this for you. In fact, for that application we were working on, you could simply type Fyne package, and it's going to create the bundle. That's going to match the current operating system, but we can specify a different operating system. It is subject to having the right tooling, and that does include a C compiler for the target platform. But this would create a Linux package with all of the metadata bundled up. And using using those bundles, we can ship them into the application space of your computer. So if you wanted to just install it locally instead of distribute it, you could just use that Fyne install command. And you can see there it's being found by my Mac launcher, and it will appear in your Windows Start menu or your app launcher on other systems as well. And in fact, we could also use iOS as our target operating system. And assuming that your phone is available and the provisioning is set up correctly, then that's going to install onto your device. So here's a little screenshot of 9 of some of my favorite Fyne apps that were available when I took that screenshot. And distribution, again, is going to be a little bit harder for applications because there's so many different ways to get this information or the binaries out to people. So we've made a release subcommand that's going to help with that. For most platforms, you'll need an app ID to register it uniquely in the world because the stores are quite keen on making sure that's set up. And here's an iOS release command. And if you pass it the profile and certificate that you've registered Apple to get, then that's going to create an IPA file or a new package format, actually, if I remember. And you just drag that into Apple's distribution app uploader, and it connects to the same store as if you were writing something native for Apple's systems. And with Android, it's very similar, but we use a key store. That's how they store their passwords. And that's going to generate an Android, an APK or a bundle that you can then use to upload to the Play Store. You just drag and drop it into their website. A lot of this functionality requires a lot of typing on the command line and subject to human error. So we created a metadata file called fyneapp.toml, and that just pulls this together so that you don't have to worry about always typing the right thing. This is a simple file like this. If you see one, you understand that you don't need to remember a lot of these parameters. And so on top of this, we added a new subcommand called Fyne get, and you can actually use, just like go get, a standard URL. It's going to discover this file exists, use the options, and install the Fyne application it finds at that URL into your system directly. So that's a pretty cool thing. So just a little bit about the way that drawing is set up and the widgets available. I'll try and run through because quickly, most of this is going to be discoverable if you start to build an application with Fyne. So Canvas, excuse me. Canvas is basically the top level element. It's the contents of a window, and this is provided by the driver that has been loaded in the app package. So it'll usually be drawn using OpenGL. It might be GLES, and the input events and so forth are going to be handled according to the platform. So it works on mobile or your desktop, and also we're have almost a tech preview of working through a web browser as well. So we're able to translate all those types of events to a standard interaction. We have primitive draw objects in the Canvas package, so you can draw lines, squares, images, circles, whatever is used to build up the scene graph or the canvas that's going to be presented to the end user. We have heavy caching on all of these items. And if you want to change something that's going to be a visual change, you simply say refresh, and it's going to invalidate just that one element. And this is one of the real bits of power of a retained mode toolkit. You don't have to worry about things that aren't changing. You just make changes that you want, and everything else is going to remain consistent. A lot of helper methods make this easy. You could just call set text on a label, for example, and it's going to make sure the right things get refreshed. So this is often happening behind the scenes. All widgets, they're a little bit more complicated than canvas objects. They have a widget renderer, and that's kind of a collection of elements that build up a more complicated visualization on screen. The widget object contains state, so you can interact and configure how it's going to behave, and the renderer controls how it looks. And that way we keep behavior and rendering separate, which is what makes unit testing possible, among other things. Like I said before, you can save what's on screen in your application if you want, using simply capture on the canvas object, which is inside window. So window.canvas.capture will give you the contents of the current window. And all of this is going to just be automatically configured for you. So you probably don't have to worry about much, but it's good to know how it works under the hood, I think. The container is another graphical object, but it doesn't really draw much to screen. It's controlling how things are positioned. So widgets themselves don't really control their maximum, minimum, well, they don't control the maximum and preferred size. They have a minimum to make sure that UI is laid out sensibly, but the container, oh, sorry, that, so that text has not presented correctly, has it? Sorry. The container is setting up multiple items on screen, and its layout is going to be used to determine how the widgets are laid out inside the container. And this way allows us to be adaptive to different window sizes, making it lay out appropriately for different types of devices, different available space. And apologies, I seem to have two different slides combined to one there. You can see in the diagram there, we have a container with multiple things. There's some canvas objects, there's some widgets, and we can also provide our extended or custom widgets inside the container, because the inheritance approach just allows it all to work together. In terms of widgets in the standard library, there's quite a lot available. We have a label, as you might think, with non-interactive text. There's a button that can be tapped, can have icons in. I have a progress bar, card for grouping elements, which might be familiar to anybody who's worked with material design before, which is where we get most of our design inspiration. We have a rich text widget now that you can work with either directly through the API or by passing it some markdown, which it will interpret for you. There's a text grid for more complex text systems like a terminal or code editor, for example, hyperlink, other things like toolbars and tab bars, and a split container as well that users can drag around. And all of these things are quite basic, but they provide enough to create an application layout along with the containers that I mentioned. But also, of course, you need input. So the standard thing there would be entry. We have a password entry, slider, a checkbox if you want to have something on or off, or a radio group to select multiple items, and a select an alternative form there to pick something from a list. And there's variants of those as well, with validation and forms that have more complex validation as well, that can help you to give a good user experience when they're inputting stuff. And as you can see, all of these widgets are going to adapt to the light dark mode of your system, and also to the current theme. There's a standard theme built in that's light and dark options available, but your application can provide whatever it likes if it wants to override that. And for applications that have got a real heavy workloads or massive data to work with, we have these collection widgets, which have their own caching and performance systems, so that it's only rendering what's necessary on screen. So if you imagine 100,000 rows in your database, you could use one widget to present that. And the way it's working is by asking you through 3 callbacks. Firstly, how much data is there? So it knows, how much space or how big the scroll bars need to be. It asks for a template object, and that's showing the system how to create a new instance of a row or a cell or something in your collection. And then the third callback is what you're going to use to set the data into this template that's been retrieved from a cache or created. So obviously, on like the screenshot there, you might create 10 of them and when the screen is loaded, but then probably reuse mostly as the user scrolls. And you're just responsible for taking the data, grabbing it from your data set with that index and applying it to the widget. So that works for list, and we have the same approach for table. Obviously, that's 2-dimensional instead of 1, and a tree, which allows you to specify parent-child relationships, and things can be collapsed, as you might expect. So that's the individual elements that make up a user interface, but we wanted to provide functionality that will help with standard workflows. So dialogues is obviously one of those things. Confirmation would present something, as you might imagine, just allowing somebody to feedback a true-false response, whether they're happy to proceed. And then the file picker is a little bit more complicated because the callback gives you a reference to a file, but it's going to open something that would, again, be quite familiar for your users, but still just a single line of code. So this takes us into file handling, which is a little bit complex, along with how we manage cross-platform storage. So although even with the latest Go file and IO, there's still some challenges with cross-platform access for safe files. We don't know that the data is coming from the file system necessarily. If you're picking something on your iOS or Android device, it could be coming from a different app. It could be coming from outside a sandbox. Or if you're on your desktop computer, the abstraction that we've written means that your data could be coming from a network file share or something that's not currently mounted. You could even be browsing the contents of a web server if you so wanted. On top of this, we've made a simplification of basic file storage so that your code could just say, look, I want to create or write to a file with this name, and it's going to take care of all of the complications around how the file system works, where the permissions exist, and that integrates with the file picker widget dialog, that we saw earlier. There's additionally a preferences API. App.preferences is going to return you an object that allows you to simply say, I want to store or retrieve a value about this user's metadata. And so it's going to do the right thing on different platforms. So that is persisted for the user without needing to worry about storage at all. So you can avoid what a lot of apps are doing with JSON, marshalling in and out of memory using JSON. The Go APIs are powerful, but we managed to avoid them completely. And data binding, which is where a lot of power is added because your user interface doesn't necessarily want to care about taking the data, applying it to a widget, listening for change, writing it back again. So this is where data binding comes in. I want to show just a little bit more. So we've simplified the type system a little. For each of the different types, we've provided basically the highest level version of it. So instead of float 32, float 64, we just support the 64-bit float. To take a little complexity away, you might need to upcast a little bit, but we think that it's worth it for a clean API. That's to bind a simple primitive. We also support binding lists and maps, where the API is similar to the primitive type, but it's got appropriate callbacks so that any changes are going to be mirrored. We have a struct binding as well, which internally is using some reflection and a map so that you can take your custom struct and map it into the user interface without having to write a lot of code to interpret the struct. And of course, we're binding into preferences as well. So you can connect your widget to a stored value instead of just a value in memory. And sometimes the binding is not going to be quite the format that you want. So if we have a float that's coming from a data, an item of data that is a floating point number, but we want to display it in a label, the two are not going to match. So before generics existed, and perhaps for a while after, we provide these converters that mean that you can either with a standard format or with your own format, apply a conversion. And this, like all of data binding, is two-way. So if you were to bind that to an entry and somebody typed value 6, then the value of 6 would be saved into the float rather than trying to marshal a string, including the word value all the way back. And this leads to some pretty powerful setups. So here I've created a new entry widget and I've told it to bind to some data. And that data is a preference binding to a string stored in my preferences called Note 5. As you might imagine, this is part of a Notes app. And what that means is the right-hand element there, which is a multi-line entry, has its content retrieved from my user preferences. And anytime it changes, it's persisted directly back to those same preferences. So I needed to write a little bit of code to determine how to add and remove a note. Mostly it's in incrementing that integer, the number 5 there, and keeping track of how many I had. But absolutely all of the other I/O and handling of state is done by the data bindings. It's a very simple app. And I'll show you where you can find that later. This one's not public API yet, but we're working on cloud integration as well, because of course, none of these popular apps are going to be working in isolation. But all of the APIs that we have are going to work with cloud data providers, just like they do with your local data. And so the API work in progress is exactly the set cloud provider, and you can pass it an instance of a provider object. A standard package will provide standard cloud connectors, and there's future work to allow users to decide how they want their data to be persisted to the cloud. So a lot of power coming in through additional APIs, plugging into the standard ones that we created over the last few years. So just quickly before I wrap up, I wanted to show you some apps and where you can find more information. So here's an illustration of some of my favorites. The Notes app again, a chess game, which I made a tedious 3-hour live coding session compiled from different live coding sessions, but nonetheless showed how drag and drop can work and loading graphics and so forth. A terminal is almost mandatory and part of a desktop environment for Linux and BSD back there as well. And on the left-hand side is an application for managing applications. So you can actually install using the same command line tools that I mentioned earlier behind the scenes, but you can browse and install Fyne apps. And these can all be found at apps.fyne.io. It's a place that we list all of the known open source apps that people are happy to have shared. Not really all known, all the people have submitted. In fact, you could submit your own if you have a Fyne application and you would like it included. Just go to developer.fyne.io/submit, and it will ask you for appropriate data and license. Make sure it's compliant, and it will get added to that page. And if you're browsing there and you want to know what's available on mobile devices, there's some links in the menu there so you can see what has been uploaded to the Apple App Store and the Google Play Store as well. So you can see how some of these applications adapt on mobile. So if this sounds really interesting and you'd like to get involved, firstly, you can find a lot more information. We have the main developer documentation is at developer.fyne.io. And if you prefer video tutorials, we have a YouTube channel there as well that we're just refreshing actually. So there's 6 or 7 new videos and we're adding to that every month. And there is another book, sorry for plugging, but last year with the release of version 2, I coordinated another book launch, which is essentially the guide to building Fyne apps, getting started and working through a lot of the APIs in detail. So I'd love it if people bought that book, and I hope it's helpful. But if you'd like to get involved in developing the project, contributing, that would be fantastic. We're looking for people who can help with the code, the testing, documentation design. I mean, you name it, it's an open source community that is always looking for more help. You can find us on GitHub. We're also looking for sponsors who can help keep things running. We're starting a bounty program, and so if you have a particular bug or feature that you would like to see addressed, a small bounty will be passed on to the person fulfilling a bug that a sponsor has nominated. And that helps to send a little swag to those people who are tirelessly volunteering to help out on the project as well, which is always appreciated. And lastly, I would be remiss if I didn't mention that there is commercial support available. If you would like to join the group of people who are using Fyne in some business product, or you're just looking to have more dedicated support available, you can come and talk to me or any of the team at Fyne Labs. You can find our information there on the web. I hope that's been a helpful introduction or refresher or a tantalizing idea about what can be done. I know I've veered off from what's possible with Go GUIs and definitely headed into what Fyne is going to help you do. But, you know, I think that's a good way to go about it, though other options are available. I'd be happy to take any questions now if there's time, or if not, you can hit me up on social, and the go for Slack is a good place to start. There's a lot of Fyne channels there, and there's a dedicated community who just loves help answering questions. So thanks so much for your attention.
Thank you so much, Andrew. And yes, we do have time for questions. So you have a couple options here, folks. If you would like to type it, you can do that, and Andrew can read the question out loud in the chat, or unmute yourself. And we'd love to hear your voice as well, and just ask Andrew directly.
Hi,
hey, Andrew, I've got a question.
Yeah, sure. Was that Austin? Sorry.
Yes. So sorry, I think I might have interrupted somebody else as well, but
Go for it, Austin. I'll go next.
anyways, first, thanks so much, Andrew. It's very interesting. My name's Austin. I'm an Android engineer at Morgan Stanley. I do not work in Go. However, I am a huge fan of the language and the community, and I've done several kind of personal projects. So I'm interested in applying Go to Android. So having said that, traditionally Android apps have been written in Java, and now they're mostly written in Kotlin. The user interface portion of that, pretty much all apps now that are being supported by large companies use reactive, interfaces like you were saying with binding the data to the UI. This was originally with RxJava. Now it's with live data in Kotlin anyways. But for Fyne, is there future, does this exist now, or is there future support for more like complex reactive operations? Like a really common scenario for our app is like, we receive a bunch of data from the back end, and we have to use maps and filters to transform that for it to be suitable for the user's experience. Is there any support for maps or filters or other more complicated reactive patterns?
Yeah, so I mean, the data binding is definitely the place to go. And if a widget supports binding, which many of the standard ones do, but we're rolling out all the time, and things like table and list are not quite there. We're working on it right now. Well, I think list does, but table and tree, we haven't got the data structures just right. So that's in the next release, we hope. What I failed to mention, I suppose, is that all of data bindings can be implemented custom in your code as well. So you can implement the string binding interface and provide any data source that you would like. And chaining works as well. So you can map, filter, whatever you would like. If the output type matches a widget that's available, then it's going to plug in just as you might hope. And custom widgets could also accept custom data types, and this two-way mapping through the entire chain is just going to work for you. I suspect there's complexities to your particular use case, and I could certainly chat through that a little bit more. I suspect that the standard library is not going to provide everything that you need, but we've designed it to be extensible so that your code can add to it and put that complexity in, but still get the benefit of the simple, easy to use API and the standard widgets.
Awesome. Thanks, Andrew.
Can I ask a follow-up question about that? Was actually quite similar to a question I wanted to ask, actually. Related to the data binding and sort of that reactive model, what's your take on React, let's say React Native? Maybe that applies a bit more closely here, and specifically with what they've been doing with changing the language, adding JSX, and the language support to define a component tree, and having the data binding really as part of that, as opposed to callbacks and the sort of imperative style that you've described.
Yeah, I mean, I don't know the specifics, honestly. You can't really keep up with what everybody's doing. We started with a vision and ambition, and we're still following it. Other people may choose to catch up or progress well in parallel. So I couldn't really comment particularly. The object tree and the way that callbacks are going to function with data models has been basically coded into Fyne using standard Go functionality. You have a tree of structs instantiated essentially in memory. So the reason that we can capture a screenshot or render your entire UI to XML is because we have a tree of all of the types and their states in memory, and we're rendering that through the driver, through the pipeline. So there's a lot of really exciting things we can do that are going to yeah, provide that kind of functionality, and the state could be provided through binding rather than just directly. So if there's something that we're missing, I think there's good opportunity to match what people are finding to be good experience elsewhere. But so far, I don't think anybody's come to us and said, I wanted to move from React Native and this isn't possible. The only chance, sorry, the only time we really have people go, this is not what I was looking for, is perhaps in the look and feel. And so we're not matching the system look. We're not matching whatever somebody else's toolkit is trying to do either. It's material design inspired, but it's something slick that's going to work on lots of different platforms. Don't imagine that answered your question directly, but hopefully it's sort of rounded off the corners, and maybe there's some more follow-up questions that I can help you answer.
It definitely helps. And in fact, you've kind of already answered in part my follow-up, which I don't want to, I'm happy to interleave, a few of my questions in with others. But since you mentioned it, you're sort of saying that you prefer to render your own UI across all the platforms rather than use the system native.
Yeah.
Could you elaborate a bit on why you chose to do that versus, trying to match the look and feel on different platforms? I know that there are some toolkits, you mentioned Qt, that kind of renders their own UI on all the different platforms. You can choose which flavor you want, but they also have renderers that are, let's say, iOS or macOS like, even though, you could use their standard widget sort of look and feel on that platform if you want as well. They're not actually using the native UI in any of those cases either.
Yeah. No, it's a good question. And it's, there's probably different answers, really. You're quite right. Not many people are using the actual native components, although AndLabs UI is doing exactly that. And it's great if you want a simple thing, but unfortunately it ends up with lowest common denominator widget sets, which is not particularly compelling. Many places are going with matching the system, and you can trace that all the way back to Swing if you want to. I mean, it didn't do a great job, but it definitely tried. The challenge is that now operating systems don't stand still, and how it looks is a differentiating factor that they are iterating on every single year. And we now support a combination of about 26 architectures across 9 operating systems. And if we tried to keep up with all of those look and feels, that would be difficult enough. But then consider that Linux has different theming capabilities and different toolkits that everybody expects everything to match. And so we basically went, there is no way that we can match everything on every platform. And in fact, some of them are pretty terrible in our opinion. Others are excellent, and we're not going to be able to absolutely meet that. But let's do something that's great on everything. And one benefit that gives is that if your application looks good on your development platform, you can then build that with confidence for all other systems, and you don't have to go through and check whether the contrast is good, whether the widget set matches. And so the experience and the confidence it gives for cross-platform rollout is actually a really great benefit of something that perhaps was a tough decision early days.
I guess that's from the developer's perspective. What about the end user perspective? Something that's familiar, to them in terms of UI.
So, I mean, we're confident that being easy to use and obvious on how to use is more important in UX than matching the graphics or the visuals of any given operating system. And that was harder to justify a few years ago. But now, like, I challenge you to open a brand new iOS device and find 5 Apple applications that actually use a consistent standard widget set. They've given up on it. So, it's kind of hard to say it's definitively required. When I started work in mobile, I would have agreed you had to look like theirs or it wasn't going to work. But the differentiating, having an application that looks clean and clear is so much more important than matching the specific widgets. I mean, in our opinion, this is quite subjective, and I understand that not everybody will agree.
Great. Well, thank you so much for the answer, Andrew. We have to, Melissa, you have a question, and after that, why don't we go to Mofi's talk? But I love the interaction. We can save some more questions at the end as well. So I'm definitely want to get people's questions in as well. But Melissa, please go ahead.
Yeah, my question, if you find it more relevant for the end, that would be great. I know we don't want to cut short the next talk, but Andrew, we had a quick chat at the beginning talking about your background coming from Java. And I also have a background coming from Java. I am new to this group, so bear with me. I'm hoping that other newbies will benefit from this question. But I worked with Go several years ago. I was on a team, and we had a project that involved scheduling and stuff. So it was basically just cloud services that we were running that we used. We were a small team, so it wasn't a huge issue, but I eventually did run into problems with dependency management. And keep in mind, this was prior to like when modules were introduced. So for someone new on the scene coming back in, which I am, and after watching your talk on Fyne, I'm like, wow, this is cool. I want to take a look at this again. But originally I was pretty disappointed in the dependency management since I was so used to Maven projects and being able to control that reliably. Can you share your experience with that?
Yeah, I think you missed the hardest part. Moving from what existed to what we have with modules was
exactly
a very big pain. And we, as a project, kind of followed the rules to the letter in a way. We didn't try to fight the new system, whether we agreed with it or not. I think we've all experienced questioning the core Go team and realizing that they had really good reasons, and it's easier to go with it because they know what they're doing. So we did exactly that. And the move to V2 was a challenge in many ways, because that broke our dependency chain, and we saw a lot of dependencies not working with modules as we were moving to V2 as well. I think that now we're in a very good place, and the module file now is doing a much better job of managing dependencies than some other platforms have. It's not as rich as your Maven POM file, and I'm not saying that just from a biased point of view, but it's sort of stripped out the stuff that's not really needed. And unless you're getting into complex trees where some things are depending on other things and there's breakable APIs and one needs it and one doesn't need it, then you're not going to need that complexity. And if you follow Semver and the basically just use Semver kind of approach that the Go team is putting out there, it does seem to work really well. And we've definitely seen huge benefit, especially like in building these graphical applications. We've just put together a components site that I forgot to mention, actually, addons.fyne.io. So somebody builds a widget and they can then share that's available, and you just do go get or mention the package import path in your code, and the tooling is going to be able to grab it, connect it, and the widget is going to drop into your UI in seconds. And I haven't experienced that with anything else. I know that JavaScript and web tech makes it possible, but it does not make it slick. Does that answer the module side of things?
It does. It does. Thank you very much. I was just really curious about your perspective.
Yeah, happy to talk at length about it because there's definitely a lot of detail in there. But we're in a good place now, and there's still chat back and forth. But I think if you go with what the tools want you to do, you'll have a good experience.
Awesome. I'm ready to try it again. Tell you what, it looks
fantastic. Cool. Oh, thanks so much. Right. I noticed just very quickly, if there's a moment, somebody asked about customization. This does come up a lot, and I can answer it quite quickly, I think. We definitely want to be able to have applications convey brand. That's going to be important. Nobody wants to have a generic looking user interface. And you notice the Notes app and others pop up through the presentation show that it's possible. So we support theming through an API. It's not a skinning system like some technologies, CSS not least, of course, on that list. So if you can describe the difference in code or a JSON metadata file that we can load into code, the sizes, the colors, the fonts, the icons, all of those things can be customized as you would like. And I think drop shadow depth is one of those things, and drop shadow color. However, you're not going to be able to make absolutely everything different. So if what you want to customize is something that we currently support, you're sorted is great. If you want something that's a little bit different, then either it's a customization that doesn't fit within our interpretation of material design, in which case you'll need to code the widget manually, which you could do, or we've missed something, open a pull request, and the team's really great at adding that to the next release, and that gets added. And we're always looking to expand the theme API One of the changes in V2 was to make the theme API extensible without breaking changes, because the first API design for theme was set in stone, and we completely made it too hard to customize, to expand. It's now very easy to. So we're always looking for feedback and what to add. Sorry if that was just extending the time a little. I'll hang back, and if there's questions at the end, I'll answer them too.
That's awesome, Andrew. Thank you so much. And again, everyone, if you have some questions, we definitely don't want to shut them down. Definitely at the end, we'll be able to do some more. And without any further ado, I want to welcome Mofi. Love your email address, Mofi Codes. Always easy to remember. Branding that is amazing right there.
And I try to code, so it's true.
Yeah.
It'd be like, like Mofi good codes, maybe probably would have been alive, but Mofi codes, absolutely, I code a lot.
You didn't have the word spaghetti, which is a good thing, right?
Oh yeah.
I
mean, I think that's one of the things that makes me love Go, that it's possible, but you have to push really hard to write spaghetti code with the import being one directional, right? So you can't easily just like import A here and B from A and A from B. You can't mix it up that badly. The language itself yells at you enough so that you can do those kind of things. Hello, my name is Mofi, and I'm going to share my screen before I forget, because if I don't, only I can see the talk. Okay, so if anyone who has a camera on, give a thumbs up that you can see my screen and hear my voice. That would be awesome. I see Andy, so I know someone can see it. So the talk is titled Go Channels Demystified. If you have been around in the Go community or dealing with Go for more than some time now, you have probably seen channels. My first introduction to channels was, like many of you, from the tour of Go, and like Andy, I also forgot what the link is now, but there is a website you can find out how to learn different Go things. Channels was one of them, and channel syntax looks like an arrow pointing like to the left both ways, and it kind of brought a lot of PTSD for me. Like I used to do, like back when school, when I was learning C and C++, they have all the pointers notations look like an arrow, and I have nightmares about them sometimes because I was bad at memory management. So when I saw the pointer, I'm like, oh my God, this is gonna be terrible. But then I kind of like got interested, learned about channels a little bit, and it wasn't bad at all. One of the best things about Go is, and at least for myself, I can jump into pretty much any Go file, source code of Go, and kind of understand what the code is trying to do, especially with comments, makes it even easier. But even without comments, Go is one of the languages that are designed to be readable more than just writable. So I read the source code of Go, saw some talks, read up a little bit on how channels work, and it makes a lot of sense how channels do what they do. So I thought I would create a talk, share the mysteries I had about channels and how I kind of got over them, and help someone else understand how channels do what they do. And hopefully in the end of this talk, we will all have a better appreciation as well as understanding of what channels are. So without further ado, okay, here you go. So what are we going to do? So we're going to have 4 things we want to get done today. 1, what channels are. Next, we should try to understand why channels are there. And next is a little bit of how channels work. And this part is super optional. 99.99% of us don't need to know how channels work. We can trust the Go team for the most part that they knew what they were doing when they wrote this code, and channels do what they claim to do. So probably don't need to know how channels work, but Go being an open source project of programming language, you can just jump into the source code to see why certain things behave the way they do. And finally, a little bit about when and where you should use channels and how you can use channels to build your application. Now, that part is kind of in the end, but it's not like the emphasis of this talk, because we can have a whole conversation about how to write concurrent application with Go and how Go concurrency works. And that in itself is like a much broader topic. There's a lot of great talks on the internet, especially from the Go team in the early days, talking about the philosophy of Go and how you can write concurrent application. So my name is Mofi. I'm a senior developer advocate at Vonage. I write a lot of client SDK stuff, and Vonage is a API service company. We have a lot of SDKs for text, videos, messages, phone calls, and I mainly deal with these days JavaScript, Go, and Java SDKs. Although Java is not my, I'm just helping out in the Java SDK side. In a past life, I used to do Java full time, but I came to Go, like many of you, from the Java world, and simplicity of reading Go code, where it is very difficult to write, difficult to read Go code, made it very enticing to me for me to learn Go myself. So if you're in the same boat coming to Go from Java, you're in good company. I think like Go is an interesting language. It's a fun language to learn, fun language to code in. And if you need to find me after the talk, I am on the Go community Slack as well. I think I'm called Rahman or Moficodes, but in the social media, I'm also called Moficodes. You can find me there. You can chat more and either rant about other languages or talk about our loves of Go. So both are welcome here. And if you want to follow along in this talk, the slides are in this link. So it's tiny.cc/go-channel. So if you want to find the slides to this particular talk, the link to the slide is in the link as well. So you can jump into that if you want to. Or I'll share this link later in the Zoom later, so you can find the link to the talk later as well. So there are a few short code examples here, and I use this handy dandy cross versus tick mark symbol on the code. So if the code is supposed to be able to run on your code, you can just type in the code, it will have a check mark. If you have a cross, it is either not going to compile or your editor is going to yell at you for whatever reason, because not all the code examples are complete. So what are channels? So if you look at the definition of channels in Go, the definition you're going to get would say something similar to this. Channels are typed conduit through which you can send and receive values with the channel operator. So a channel operator looks, as I said, like an arrow with like a greater than sign and a dash. And typed conduit. This is one of the things when I first read it, I was confused about, because until Go 1.18, Go doesn't really have a generic. So channels, we can create channels that are typed, but Go doesn't necessarily have a generic type system. How does channel types then work? How does channel become typed? So again, we can look at the source code later. That's kind of like kind of hacky, kind of interesting way how Go channels kind of maintain their types. But the idea is channels, like the name says, are conduits where you can pass through values through the channel. One of the things you're going to notice, channel itself doesn't necessarily care that you are passing the information to a different Go routine or not. So channel doesn't necessarily need a Go routine to operate. So that's like number one thing you want to understand. Some of the features of channels, number one, they're Go routine safe. So if you have seen channels before, chances are you have seen that in the context of having multiple Go routines, channels passing data through, and you're getting the data from another Go routine. But channel itself doesn't really care that they're being used in Go routines or not. Next up is pass data between Go routines. You can do that because they're Go routine safe, and you can pass data from one Go routine to another. You can block and unblock channels. So you can create a channel that can block the execution of your current Go routine. And it works like a queue. So if you have a channel that have a lot of data, the data will be taken out in the first in, first out order. This becomes important when you're trying to create some sort of pipeline where you process some information, pass it through some channel, and you want to get it on the other side in the same kind of like whatever you send, you want to get it on the other side and build a pipeline that way. Channels are typed, so it's a typed conduit. You have an int channel, and you wouldn't be able to send like strings to an int channel and vice versa. And channels can be sending, receiving, or both. So you can have a channel that is just receiving data, and if you try to send something on it, it's going to yell at you. It could be a sending channel. If you try to receive something from it, it's going to yell at you. Or you could create a general channel that you can both send and receive data from. So when you read about channels, there are basically two basic types of channels. Number one is the unbuffered channel. Unbuffered channel is basically a buffer channel of size 1. You can only send one thing at a time, and you can only send something again once that thing that you sent before has been taken out of the channel. So example, again, me saying doesn't probably make sense, but example, it has a cross next to it. Basically, this means if you were to write this code would not actually run because it's going to deadlock. Why it's going to deadlock? We're going to look at it in a second, but let's just look at the example. So we have your classic package main import func because we're trying to print something, and you have a main function. So we have a channel declared with C equals make channel int. So we're creating a new channel which has a type int. And then first thing we try to do is send something to this channel. Because it's an unbuffered channel, every send must have a receive. So you might notice that there is a receive right in the next line, but we're in the same Go routine. So when you try to send something in this line right here, your Go routine, this Go routine is going to block, and we're never going to reach this line of code, and we're going to deadlock. So So this code is never going to compile. So how can we do something different with channels? Well, how about we create two Go routines? In this case, we're in the main Go routine, and we're going to create a different Go routine. So in our Go routine, we're going to send something in our channel. This particular application is actually going to work. So we have a channel that is of type int. We call this Go send, and which is going to send the value 1 to our Go routine into our channel. And then the next line in our main Go routine, we try to read the value that is in the channel C. And if we try to print this, this should print 1 into your terminal. So we basically are reading something from the Go routine right away. I'm going to have the chat open on the side just in case. Yeah, so again, this code is going to work because we have two different Go routines and our code doesn't block. We just come to this line, we create a new Go routine, pass in our channel, we send something to our channel and read that immediately. So this is also unbuffered channel, but it's not blocking anything because we're in a separate Go routine. Okay, next up, send only or receive only channel. So it can be created to be sent or receive only. It can also be created by passing it to a function. In the previous example, the channel we had was basically a both channel. It was not specified, but when we passed it to the function, we actually said the channel we're going to get is going to be receive only, send only channel by pointing the arrow towards the channel itself. So this is saying this is going to be a send only channel. So in this, within the function, if I try to receive something from C, that would be a compiler error because within the context of this function, this channel was send only. So we could either declare when we were creating it or when we were passing it to a function, we can say within the context of this function, we want this to be send or receive only. All right, so again, the example, we could create a receive only channel by pointing the arrow away from the channel, or we can create a send only channel by pointing the arrow into the channel. This code, once again, is not going to compile because we have two variables that doesn't get used. So Go doesn't like not unused variables. We could create this example as well. So we have a channel that we created and we have a function called receive that takes in that channel, converts into a receive only channel. And you have a function send that takes in the channel, converts that into a send only channel. This code will work, but it doesn't do anything. So it's kind of useless. So let's now talk about the type of channel most of you are probably will be seeing or using for different things. The unbuffered channel are not used all that much other than signaling. We'll talk about what that means in a second. So buffered channels. So buffered channels is a blocking channel too, but it can be non-blocking to some capacity. So you buffer channel, you can think of like a queue of size n. So whatever size n happens to be, while the size is not full, you can keep sending and it's not going to be blocking. The moment you fill up the channel, that's when it starts behaving like unbuffered channel. It blocks your execution path. So buffer channel, in this example, we have a buffer channel of size 1. So we can store up to one thing into the channel without it being blocked. So we can send 1 to C because it has a size of 1. We can take on the value without blocking it. We can go to the next line and B can read the value from C, and this code will execute just fine because nothing was blocking. And all this time we have been, this example, as you can see, channel, we don't necessarily need to have Go routines to use channels, but Go routines is where channels really shine because channels can pass data between Go routines. Okay, so these are some handy dandy chart. I basically found this on some blog post that was talking about how channel states work, and I thought it was a really easy way to visualize like all the different operations you can do on a channel. So on the top, we have all the different states you can have on the channel. So you can have a nil channel, a channel that hasn't been initialized. You can have a channel that is open, and you can have a channel that is closed. And the operations you can try to do on a channel can be receive or send. So if you try to receive from a nil channel, that is going to block your code until something changes. If you try to send on a nil channel, it's going to block until something changes as well. If you try to receive from an open channel, you should receive a value that is in that channel. If you try to write to an open channel, you should be able to write whatever you want to write. If you try to read from a closed channel, that is actually fine. You will actually get a default value. And the second value, just like you get from map, that is going to say false. So you will get default value for int is going to be 0. Default value for Boolean is going to be false. So you're gonna, if you were to read from a closed channel, you would get 0 and false if the channel happened to be integer channel. And if you try to send to a closed channel, the code actually is going to panic. And then these are actually all the different states that are possibly there. So if it's a buffered channel, open is not the only state there. There are open but empty channel, open and full channel, and channel could be receive only and send only. So I just thought it would make more sense to extend out this particular chart a little bit more for people to understand. So if the channel is open and empty, and if you try to receive from it, if it's empty because there is nothing on the channel, that operation is going to block. And if you try to send something in an open and empty channel, that obviously is going to work. You can write the data there. If it's open and full, on the other hand, receive will definitely give you some value, but send will block. If it is a receive only channel and you try to send to it, this is something the Go compiler can actually catch. So your code actually not going to compile. IDs like VS Code or Golang that has really great Go support. If you write a code in a function that you do the arrow pointing outwards and try to send something to it, your ID is going to yell at you. So you wouldn't be writing this code anyways, which is great. Your text editor can help out as much. Same thing with the send only. If you try to receive something from a send only channel, your ID is also going to help you out and not going to let that happen. You can also close a channel. A closed channel is a great way to signal different things that are waiting on a particular channel, because one thing you can notice when you're trying to read something from a channel that is closed, you can always get data. So if you're, let's say something is waiting on a channel and that is blocked for whatever reason, if you close that channel somewhere else, all of a sudden everything that is waiting on receive now gets unblocked and gets data. Okay, so nil channel always blocks. So nil channel is again, if you look at some of the more advanced kind of patterns on how to use Go channels in Go concurrency, you're going to see that nil channel is a way you can kind of block and unblock certain paths of execution in your Go routines. So for example, in this case, we create a varc channel int, which I don't call that make. So this channel is nil. So when I try to read something from it, it's going to block. My code is going to eventually deadlock. I'm not going to get any value out of that. So this code will not actually run. It's going to deadlock because I'm not going to get any value from it. So closed channel never blocks. If you have a channel that is closed and you try to read some data from it, so you have a channel that is C, we can create this new channel of type int. We close the channel immediately, try to read some data. If I try to print that data out, you're going to see that data is printed as 0 because, again, closed channel, it doesn't block, just sends back the default value. Closed channel returns the default value for the type. In this case was int, so we got 0 back. For other types, it could be empty string or false or what have you. It also returns a second value that denotes the channel is open. So for example, if I were to do a D, OK on this first example, we would get a true because channel was OK to read from. Once we close it, this OK is going to give us false because now we're getting default value and the channel is closed. All right, so one of the, from Gopher Fest 2015, Rob Pike gave a talk called Go Proverbs. A lot of the later Go talks from then actually uses a lot of his quotes he used in his talk. So one of the famous ones he used there was channels orchestrate, mutex is serialized. So if you're coming from a different language that has some of the different types of concurrency primitives like mutex and locks and other things, you are familiar with using those, and Go definitely has those tools to build concurrent application. But the differences being mutexes is a way for you to say, this is the point in my code where I want all my different concurrent data to converge. So I'm going to lock this particular piece of data. Everybody has to wait here. Once I unlock, I will kind of serialize all my application, all my different Go routines to go through this path of execution. In the other way, channels, the way channels operate is you're passing data between each other and they orchestrate the structure of your concurrent application. So if you can, in your head, think of a model of how you can represent a concurrent action happening, and you just need to get the information from one another, that's where channels fit in really nicely in the Go context. So a couple more primitives for using channels well in Go is one of them is select. So select is statement lets a Go routine wait on multiple channels at once. So you can have a select. It's kind of like a case, like switch case in Go as well. So you have multiple cases that you can like wait on at the same time. But the difference is between switch case. In a switch case, you are switching between a similar type of data and it's just different variations. It's like if else, right? If this is true or this is true or this is true. Select, you can basically wait on arbitrary number of channels. You don't really have to worry about if these channels are related to each other in any way. So select is blocking. So if you just have a bare select statement, that is going to block your code forever. And this is also not going to run because it's going to deadlock. So you need to make sure that if you have a select statement, at least one of your Go routine, one of your channels within the select actually executes and does something. So it is like switch case, but not really. The difference being is Go runtime does not care what channels you select on. Responsibility of composition is left for the user. So with great power comes great responsibility. So because you can pretty much select on any channels, that means as a developer of the program, you have to make sure the channels you select on makes sense to be grouped together in some way or fashion. So there is also force select. Force select is a way you can indefinitely loop through a bunch of Go routines and channels for data to come back. This is the way you would oftentimes kind of combine and orchestrate multiple Go routines passing different types of data back and forth and have a force select infinitely listening for those things and take actions. So you can do long-running select operations on a Go routine with force select. So one example of force select here, as you can see, we have a channel of CH and we have a force select. And in the first case, we're waiting for some data to come out of CH. We're going to put that data in this variable called D, and they're going to print that data. And the other case we have is after time 3 seconds. This is a built-in type time. Built-in module in Go called time, which has a function called after, which returns a channel that like you can pass it some time, and after that time passes, that channel is going to send some data back. So basically, you can receive some data after 3 seconds, and after 3 seconds of waiting, we're going to see that this function prints times up. Okay, and at this point, this is actually all the things that exist in Go channels for you to kind of take all these parts and build out the next great application using Go. So if you wanted to just learn what all the different things in channel exist, this is all you need to know, and we can stop at this point. But given we have some minutes left, I'm going to just quickly go over some of the things that I think makes Go channels pretty interesting. So let's talk about why of Go channels. So one of the other proverbs from Rob Pike's talk was, do not communicate by sharing memory. Instead, share memory by communicating. So when you have this code concept of using mutexes and locks and other things to basically say, this part of the memory of my application, I only need to give access to them, whoever has access to the key to this lock, you're basically stopping every single Go routine until whoever can come up with the lock to open that part of data. So you are sharing a bit of memory to communicate whatever you want your application to do. Instead, using channels, what you can do is you have multiple of these Go routines, and you can pass data from one Go routine to another through the channel, and you're basically sharing memory by communicating. You're communicating, you're talking to each other, and you're sharing information between them. So these are the kind of two different ways of structuring your concurrent application. In terms of performance, I can't really talk about one is significantly better than other. You can definitely build great applications using both ways. It is just different way to model the application domain in your head. Like, how do you think about how this concurrent application is behaving? So when you talk about Go channels, one of the other words you might hear quite a lot spoken about is CSP. CSP stands for communicating sequential process. This is a theoretical academic paper written in 1978, a long time ago, and it talks about building a concurrent application model that basically handles this concurrency by communicating with each other. And it had the earliest theoretical implementation of something like a channel. Another language that actually makes use of the CSP style of channel is going to be Erlang, and Go is one of them. I don't know if Go is like a pure implementation of CSP or not, but channels comes pretty close to the theoretical ideas of what a CSP is supposed to do. CSP is basically just saying if you have multiple of these processes, only way to make sure all of this process knows what to do, when to stop, and how to pass data is to have something like a channel where you can pass data between each other. Again, it's a paper that you can probably read. It's a pretty long and very theoretical thing, but I tried reading it. It was very just filled with mathematical jargon. It kind of went over my head a little bit. So then I looked at a YouTube video explaining CSP, which is great. But idea is you have channels, you have multiple Go routines, multiple of the sequential processes running, and you can use channels to kind of orchestrate how they communicate, when to stop, how to spin up more, or like converge them into a single point. All right, so let's talk a little bit about how the operating system scheduler works. One thing you're going to hear about Go is that Go is a low-level programming language. It compiles, it can talk to the operating system pretty easily. So how does it do it? So in operating system, there is something called a process. Everything in operating system is kind of a process. A process is basically a program in execution. So anything that's running, my Google Chrome is a process that's running in my machine right now. My microphone driver is a process that's running right now. Our webcam is a process that's running right now. So everything in a computer operating system is basically a process. So a process is when you start an application, a new process gets created. At some point, it becomes ready. When it's ready, from there, whenever the operating system has enough space to run it, scheduler will dispatch running action. It will start running. And at some point, it can either go to waiting because it's waiting on something like IO or user input, or it can get killed, or it can be interrupted by me stopping it or clicking a button, and it can go back to ready again and running again. So it's just a cycle that's continuously happening. Within processes, you have something called threads. So you can have a lot of threads in these modern machines, but the threads are still limited. It has to be created. It's a pretty heavy operation. So a thread is a path of execution within a process. A process can have multiple threads. Again, a thread is just like process is created, and it can be ready and can go to running. At some point, it can be blocked on something, or it can be put on sleep by the operating system, or it can go to waiting for the user to do something on that thread. And finally, it can be killed by the process or the user. So this screenshot was taken on my machine a few days ago. And this is basically, if you have a Mac, you can look at the activity monitor, and it will actually tell you how many different processes you have, or how many threads you have. So if you look at the list here, you can actually see that you have Google Chrome at somewhere, but you can also have a bunch of Google Chrome helper. So Google Chrome, because as a single application, it couldn't spin up as many processes it wanted, it also spun up a bunch of these helpers. Now Google Chrome can have just the Google Chrome application now have multiple processes. You can also have VS Code here. I also have Slack, iTerm. I have a bunch of other things like Firefox, Slack helpers, VS Code helpers, and things like that. Another thing you're going to notice that if you look at the number of threads, so each of these processes have a variable number of threads. Highest I can see is 37, obviously being used by Google Chrome. And you have a bunch of, Firefox is using more. But Google Chrome uses a bunch of different helpers. So in total, Google Chrome probably uses more. But the point is, a single process have multiple of these threads. Now let's talk about one of the best features, in my opinion, about Go routines. So what are Go routines? And one thing you didn't notice here, there is no thing called Go routines here, mainly because Go routines is not something at the operating system level. It's defined in the Go runtime itself. So Go routines are functions or methods that run concurrently with other functions or methods. Go routines can be thought of as lightweight threads. So it's a software-defined thread that is in the Go runtime, and Go runtime can spin up and spin down like hundreds of thousands of them very quickly. It doesn't really have to spend as much resource to spin up a new thread. So a new thread for operating system spin up time is calculated in microseconds, whereas Go routines is in nanoseconds. So you can spin up a lot of Go routines very quickly. So once again, just like a thread, Go routine is created, it's put on a queue. Sometimes it can get to executing, and sometimes it can be waiting, just like a channel. It can just block the Go routine. Once the channel is unblocking, the Go routine can go back to queue and go back to executing again, or it can be syscall or sleep because of you are trying to waiting on user input, or ask call time.sleep or something. And eventually a Go routine will exit and you will get out of the application. Every single application you ever written in Go, the first line you write func main, that's start of a Go routine. And when you exit a func main, that's the end of that Go routine. So every Go routine, every one of you have written a Go application has actually written something that goes through this cycle. Okay, so Go scheduler. So what does Go scheduler does? So Go scheduler is an M to N scheduler. What that means is you have threads that the Go runtime has control over. And on those M threads, you can spin up N Go routines. So each of the thread, you can spin up many Go routines, because again, they're very cheap to spin up, and Go runtime takes care of all the putting into queue and running it and putting into sleep and all that for us, and is extremely efficient and fast in doing so. So if you were to take a look when a lot of Go routines are in operation, so what you have, first things first, you have this P is a scheduling context. Before Go 1.5, 1.5, what you had there was a variable called Go max procs, how many processes you should have. By default, that number was set to 1. From Go 1.5 or higher, what that number got set to is the number of cores you have in your CPU. So in a new machine that has 8 cores, this P would be up to P16. You have P1 to P16 or P0 to P15. Each of those process now has a thread, one thread that gets created. And then you have this like local run queue that keeps track of all the Go routines this particular process is going to take care of. You also have a global run queue. So if some thread gets waiting for too long, we can take this Go routines from the local run queue to put them in the global run queue. And eventually whatever process has whatever scheduling context has the ability to, will pick them off the global run queue to run them. The point in showing all this is, we're going to get to that in a second. So message passing in threads. So when you have 2 different threads and you want to pass information between each other, let's say I have a thread M1 that is now scheduled in CPU core 1, and you have a thread M2 that is waiting for some information from it. What we have to do is, once we get it to M2, we're putting M1 into sleep or waiting, and M2 gets the information, and M2 might get rescheduled into course 2. We can guarantee where it gets scheduled. We do the work we need to do. Let's say I wrote an application that's like badly designed where these 2 threads basically waits on each other forever. So once I'm done the work, I send the information back to M1. And again, this time I can't really guarantee, but let's say M1 now gets scheduled on C3, because again, a thread that's sleeping once it goes to execution, there is no guarantee where it's going to get scheduled on. So it like goes back and forth. Every time you have to like pause a thread and unpause a thread. It's a very costly operation. So let's look at how does that work in Go routines. We're passing the information via channels. Let's say we have this thread M1 on C1 and this Go routine G1 and G2. And we just start executing, and we basically just context switch and pass the information. And because G1 and G2 are just software defined threads, they might even be executed on the same thread on the same core, and we can just pass that information back and forth. So throughout the entire experience, one of the things, the difference is we are not taking the thread out of context. So we can just keep the same thread, pass the information back and forth. Software defined threads are way faster in Go routines versus operating system level thread moving. So our thread where the Go routine is running never gets put on waiting, right? It's just like in the same thread, we're just passing between the Go routines, which the thread thinks it's just working. It doesn't really think that something has stopped, because the Go runtime takes care of moving the Go routine back and forth. So how does all of this work? And this part is the most theoretical part of this entire talk, right? So channel implementation can and should be treated as a black box. For 99.99% of us, it doesn't really matter, other than people in the Go team and people contributing back to the project itself to make it better. But we're going to go over that really quickly. And how does it work? So next few slides are for educational purposes only. So don't try to use your brain power too much for this. And there is a great talk I will link in the end by Kavya, who goes in great detail about how the channels work. So if I misspeak about any of this topic, which is very possible, it does a lot of crazy things. Anyway, so we should appreciate how the channels work. So I'm going to talk about this. Anyway, so the channel that we create is basically a type hchan struct. So every time you create a make channel, you get yourself a pointer to a hchan struct. One of the things you're going to notice here, I'm going to kind of get rid of most of the things in this class. And these are the 5 things I think are important. Number 1 is the buffer of unsafe pointer. This is kind of like the store of the data itself. Element type is of type pointer underscore type. This is how Go team handled generics before generics was available. I don't think channels will be written to like implement generics, but This underscore type is how channels know what type of channel it should be. And you have this send index and receive index is how you know how many things you have in your particular buffer. And finally, the lock mutex. When we say channels are go routine safe, it is go routine safe because underneath it uses mutex to serialize the information getting from the channel. So when you call channel make chan int of size 3, what we're doing is we're calling this function make chan of the Go source code, and that has a t of pointer channel type and the size int, and it gives you back a pointer to a h-chan. So we get a pointer. That's why you can just pass the channel off to other things. And once they change something about the channel, the overall global channel gets changed. So when you create a channel, this h-chan is put on the heap. That's why it's a shared memory space for all my Go routines. That's why you can actually pass channels via functions, and we don't have to use the ampersand because it's already an of type pointer. So if anyone wondered about this, like I did, now you know, you don't have to worry about it anymore. Next up, channel send and channel receive. So happy path, right? So when you try to send something on a channel, you acquire the lock, you copy the data to the buffer, so enqueue the data, and finally release the lock. So that's a simple channel send operation. When you're trying to receive from a channel, you acquire the lock, copy from the buffer to the D. So basically your D variable that you have here, you dequeue that value, and then finally release the lock. So this is channel send and channel receive. Happy, everybody, everything is working, we're happy. But what if this is not the only thing that happens in channels? As we saw before, we can have panics, we can have things like blocks. So how does those work out? So let's talk about when our buffer is full, or for receive, it is empty. What does it happen? Or our channel is nil, or our channel is closed. All these different situations are possible. So let's remember our channel operations. So we know if we try to close a nil channel, we're going to get a panic. If we try to close a closed channel, we're going to get a panic. If you try to receive from an empty channel, you're going to get a block. If you try to write to a full channel, you're going to get a block. So all these different things. So let's talk about just send. We're not going to talk about both of them. So when you're trying to send something, the source code, I don't know if the line number is still correct because this source code gets updated. So let's look at the source code of Go. So if I'm going to bump up the fonts just a tad. So this is, again, the source code of Go. This is under source, runtime, chan.go. So if you go to chan.go, that's where the source code of channel is. At the very first thing, as you can see, the type h-chan that we talked about. Let's quickly go to the make channel. We can create a make channel of type and the size. We're not talking about that just yet. So I'm going to send. Okay, channel send. So first things first. If the channel is nil and the block is true, we're going to just return false immediately. We're not going to be able to send anything in a blocked channel. If it is not blocked, we can just park the channel. Parking basically means put the channel to sleep. And we can also see that if we, where's the panic? Okay, if the channel is closed and we try to send something on the channel, that's where the panic comes from. We just basically panic because the channel is closed. If all of that is good, we can basically then do the dequeue as I was talking about. You can get the data back and finally you can call send again with the information that we got. And there are some other things happens to move the pointers around because it's basically a circular buffer inside. We just move the pointers around to make the right thing. Send on close, as we saw, like if you try to send on a closed channel, we're gonna get a panic. If you try to send with waiting receiver, immediately you get the dequeue the data and send the data to the right place. Send with a waiting receive. So send, if it's a waiting receive that exists, so you can just write to the waiting receive sudo G. Sudo G is a way, it's just when you're looking at the Go runtime, whatever was in the global run queue, one of them is sudo G. And finally, call go ready on the waiting go routine. So let's say receive was waiting on my send. So the moment I receive, when I send something, I can just call go ready so that my receiver on the other end now knows that the thing it was waiting on is now available. So this is a shortcut the Go team did to optimize some of it, which was I think a performance improvement in some of the older Go version. Anyway, so if it's a full buffer, we can't send anymore, we'll just add our Go routine to sleep. We'll just go park and it will just wait until something is received. And now we can take the data back in. All right, so we're gonna just leave the receive as an exercise. If you want to learn more, you can either watch the talk from Kavya or learn more from the source code itself. I'm gonna speed up just a little bit because we're kind of cutting close on time. So when and where to use Go Channels. Number one, when you need a guarantee of delivery. As we said, Go Channels need a receiver when you have a send. So when you want to build an application that needs to make sure that every time you're trying to send something to other Go routines, the other Go routine has to receive it, you want to use a Go routine, right? So for example, in this case, we are calling after 5 seconds, we're sending this data into my channel. On the other end, I am receiving it. If I didn't receive it, my code will actually just block and I'll never get out of this application. In this case, because we will go out of the function main, we will actually finish the application, but I will still have 2 Go routines running at the end because this Go routine doesn't get to finish. If I didn't, in this case, it will because I'm taking this data out of it. But if I just didn't have this line here, my code will exit with a 1 Go routine that couldn't finish. Signal some Go routine. So if you have a Go routine, some other Go routine that's doing something different, but you need some way to let that Go routine know to either do something or stop doing something, you can have a channel that you can either close or send some data to let them know what to do. So in this example, again, you have a same example again. So you have 2 Go routines, right? One of them is your main, one of them is the other Go routine. I'm just signaling these other Go routines. I'm sending some data. You can also signal without data by just closing the channel. So if I'm waiting on this data to be available in channel, me closing the channel in some other Go routine is also a signal that, oh, no longer wait for it. You're going to get some data from that channel now. You can compose Go routine returns. So so the way you compose different things is by using select. You can have multiple channels being waited on the same time. And once you get information, you can just basically combine them in the same place. So if you have read about like different concurrency patterns, you probably heard of this thing called fan out or fan in. Fan out basically means from a single Go routine spin up multiple Go routines, and all of them has this channel to pass the data back to the original one. And you can also have a pattern like drop. Drop is really useful in web servers when you have a lot of requests coming in, and you can just then start saying, okay, start doing some work, but now I have too much work. We don't want to do all of them. I can just give a signal via a Go routine to drop the work you're doing. So you can just save some cycles by dropping works that you can no longer perform. So for pipelines, you can just create these pipelines of Go routines. One Go routine sends data to other Go routine that does some work, sends somewhere else. That's basically just the definition of a pipeline, if you're familiar with like DevOps pipelines of some sort. And there are many more different places you can use channels. And I hate this slide because it doesn't let me talk about a lot of things. But again, channels are such a fundamental building block in Go. Many more is probably the best thing I could say here. A lot of different things can be utilized and built using Go channels, but I can't probably cover all of them here. So final thoughts. Go routines and channels are just tools for concurrency. Like every single tool, it is abusable. You can basically start doing simple things that doesn't need concurrency to use concurrency just because you have access to channels. So every time, my rule of thumb is, if your application is not needing concurrency, don't introduce it just because Go has it. It is that channels are great, but it is not the only way to do concurrency in Go. Your application model might be better served in more of like a mutex and lock situation. That might be easier for you to maintain and understand and make reason about. So if that is not the case, just channels take some getting used to how to understand. A bunch of things are running. I'm going to talk to each other. Some great references. One of them would be from Bill Kennedy, Behavior of Go, who Bill is a great teacher of Go. He has come to our meetup many times to give us great talks. Understanding Go channels. This is the talk by Kavya, I think in 2018 GopherCon. So highly recommend that talk if anyone wants to check out that one. And then we also have Curious Channels. This is a post by Dave Cheney, who talks about how the different kind of patterns of using channels for different things. So with that, again, thank you so much for indulging me for over the 30 minutes. I know some of the topics definitely did go on the more theoretical side. So if it was like getting into those things that kind of gets to the theoretical side of Go, please don't feel like you have to understand all of it. I certainly don't. But Go is one of those languages I really enjoy just reading it and understanding how the language is written. And it's probably my #1 feature for Go, right? It's very readable code. So with that, I'm going to end the talk. If there is any question, comments, I think it's open right now. And Thank you. And also it's ice one. I think it's in New York. Everything is ice. It's cold, so it's definitely ice one.
Awesome. Thank you so much. I really appreciate it, Mofi. I know that was really interesting for all of us. Does anybody have any questions they'd like to ask Mofi?
I've got a quick one.
Yeah,
Please.
Mofi, thanks for the talk. I saw all the different sort of structures of passing things through channels, fan in, fan out, and so on, and broadcast. Are you able to do like a broadcast where only the first channel gets the thing that you're sending and all the other ones are kind of sleeping, as opposed to, you know, a fan out where all the different Go routines listening on a channel, you know, kind of end up getting a copy?
Sorry, so can you kind of elaborate what is the use case for that situation? Because if you're trying to broadcast, ideally you want to broadcast to everybody who's interested, right? But are you talking about like you want to build a system where you broadcast, but the first person that takes it on, no one else should get it?
So here's an example. You've got like a primary kind of producer and multiple consumers, right? But the consumers are kind of like worker bees. You want to, you know, dish out the work to these worker bees, but only one of them needs to do the work. So you kind of want to do a broadcast, whoever's available to consume that, for example.
Okay. I think you can achieve that by using like two different signals, right? Like one of them is like a work sent out, and the other one you can probably use some sort of like a lock to say this work is taken, no one else can take it. It seems a bit hacky, but need to think a little bit more on how you can structure this, because like when you are sending out this work, ideally the person that is giving out the work can probably spin up all these Go routines to do the work anyway. So you can just like have if you have a giant list of work that needs to happen, you can just have like a loop that just creates new Go routines for n number of workers, or just sends certain IDs to certain workers directly. But if you just send out all the works everywhere and you just want one person to take it and everybody to just back off, it is kind of tricky to do that without some more coordination among the worker itself, right? So if you want to send out the work, the moment you send out the work, someone takes it, they can probably send out another signal to the channel that this work is taken, no one else take it. And that might work, but that still seems tricky.
I think you're talking about round robin in a sense, but you don't sort of know when the workers are available, you know, as the producer.
Right.
You know, you can actually do it with a semaphore. You know, there is a broadcast primitive, but I'm just not aware of how you can do it, let's say, more elegantly with channels. That was where the question came from.
I mean, again, I probably not getting the full picture just yet. So I'm on the Go Slack on the Slack. So if you want to like talk a little bit more, if you have a little bit more concrete example of what you're thinking about, might be able to, but I just don't know from the prompt itself. It might not be possible, might be possible, but just would be more interested. And it's an interesting problem.
Thanks,
right?
Thanks, Mofi.
Yeah.
Thank you.
You might be able to butt in on maybe, and I might be able to answer this one.
Okay.
So when you have multiple Go routines listening to the same channel, same source channel, and you have, so that when the producer puts a message on there, only one of them will actually grab a message. So in that way, you can have multiple Go routines actually sharing the work. So the work gets spread off across all of them. So you don't have to do anything extra.
I just want to clarify, and it might be misunderstanding the question itself. I think what he mentioned initially was broadcast and just like one of them listening. But yeah, I think if you're doing a force select on something, yeah, once it pops up the channel, only whoever popped it up gets it and no one else does get it. So if that is the case, that'll probably just work out of the box. Thanks, David. Yeah. I actually did have a question for Andy. I didn't get to ask because he was getting late. So with the what do you call that? Oh my God, my brain. Generics being finally available in Go soon. How does that affect the plans for Fyne for V3?
Yeah, that's a common question right now, because I think everybody's like, oh, finally generics, this is amazing, the language is going to be everything we ever wanted. I struggle to find any way that I will get generics into our API, like not because I don't want them or like I don't want to try and push them in, but there's not many places where they make obvious benefit. Now, the one that stands out is the data binding side of things, because we do currently have generated code that is going to go away if we move to generics, and that will be nice. However, even if we did want to pick them up, we are supporting some fairly old versions of Go because we don't currently need any new functionality, and we love to support the older devices, like I mentioned in the talk. So even if we did think that that generics were going to be good for us, we're currently 4 versions of Go behind what is just being released. So 1.14 is currently what we're supporting.
So 2023, we can start seeing some.
Well, it might jump forward a few versions. We're just trying to make it so that people can use what's installed on their operating system by default. That's one other reason to stick with older versions. It will make an improvement, but the overall API of the graphical elements, how applications are constructed and how we operate with widgets, I don't see changing a huge amount. I think that'll change over the years or over the releases as we see more uses for generics, but in the raw form, I'm not sure.
I think another question I just wanted to ask actually is that like libraries like React Native and Dart actually has a lot of benefit of being able to utilize existing iOS and Android libraries for their ecosystem. Do you have any thoughts of if that is going to be something Fyne thinks about?
Yeah, it's something we need to address. At the moment, you can access it by going through Seago. We rely on Seago for other things, so it needs to work for that purpose. Now, for iOS, that's okay. Maybe not Swift, but for Objective-C, you can call that through C relatively straightforward. On Android, it's a bit more of a challenge because you have to go through the NDK and you have to have an application instance for context. So we need to make it easier. And I would like to see an API that allows you to call out to operating system specifics. However, we don't want to make it super easy because we'd rather have the abstractions in place. So if you're looking to engage with location services, for example, we should have that abstraction so that it works on your desktop and your phone, and the code is exactly the same. So we need to make it easier, but it's not top of the priority list because not too many people are asking. Obviously, we have that code internally, so we should just find a way to expose it to a public API. But it's challenging to do operating system specifics in a generic manner.
Well, the reason I ask is because like we have for video API specifically, like doing video natively on Fyne, I don't know how that would be, but doing for video API for cross-platform like React Native and Flutter, we rely heavily on our existing Android and iOS SDK. Yeah,
so one of our commercial usages of Fyne is a remote desktop company, and they can do 30 frames a second full screen through Fyne by pushing their pixel data through to the images and using the fastest rendering method, which it's not pixel perfect, but it's good for video. That's shells.com if you want to see it. They have a public repo with how that works. We're not going to be able to do H.264 decoding for you because of licensing issues, but we can push data through to the graphics card pretty fast.
Well, yeah, but this was fascinating. I have seen Fyne before, but I think it looks a lot better when I first saw it. So
it's come a long way.
Yeah, definitely.
I think maybe David had another question for you. I'll let people.
Oh, I'm sorry. Yeah, sorry. I started asking my own question. Apologize. Yeah, David, if you had any question left, you still have your hand raised, but we're happy to. We have almost 2-hour mark. So Ari, if you want to take over, happy with that as well.
Oh no, I just raised my hand to answer that other question.
Okay, perfect. No worries.
I think we're I think we're good. Let me just go ahead and do the JetBrains raffle for those who would like to head out. And let me go ahead and share my screen. And then if people want to stay and talk Go, that's awesome. We'll keep it going. I have no problem with that at all. Let me go ahead and just share my screen. We take up the wheel of names. Let's see here. And those who entered. Okay. Can everyone see the wheel of names? All right, here we go. I don't know why my sound's not working. It usually has some great sounds. And all right, David B, you are our first winner tonight. Awesome. Let's see if we can not have David B win again. One person won 4 times last time, but
Very close.
all right. Ooh,
Where are the rest of the names?
Dave Z. All right, good deal. I guess you have to be a David and a word Dave to win. So Dave B and Dave Z. And last, but by far not least, Xavier. All right.
I think the trick to have VI in your name. I don't think it's just David.
Yes. So
I think you have
Dave
to have-
B, Dave Z, and Xavier, you will all 3 get, I can't promise exactly when, but it's going to be as soon as I can. When you do get them, please go ahead and what's the word I'm looking for? Activate them as soon as possible. So JetBrains continues to support our meetups and give them to us. If they're not activated, they eventually reduce the amount. But our groups have been pretty good about it. But I usually always say that. So activate it as soon as you can. And with that being said, for those who are going to be leaving, thanks for joining us. I did have one question that I wanted to ask first. And for those who, before we head out, I almost forgot. I'm going to put this poll up really quick. And this is really, really quick. This is just in reference to doing a DevOps for Go workshop and the time of day in which it would be. So if you don't mind answering the question, so I could just kind of figure out if this is even a realistic possibility. And with that being said, please, any other questions or any other thoughts, please continue.
I've got a question for Andrew, if you're still around.
Yeah.
Thanks, Andrew. Thanks again for your talk. You know, during your talk, you mentioned Fyne Cross, and I checked it out between the talks, so thanks for that. I'm most interested in whether or not you can do continuous integration on Linux and, for example, hooking that up to TestFlight. It looks like you can't yet compile an iOS app from Linux yet. Are you working on that as well? So Fyne is a cross-platform, project during development, not just for the final targets?
Yeah, absolutely. So we're doing, this is about to sound a little bit cop-out-ish, and I'll explain why it isn't, but we're doing the best we can. And the reason that there's some challenges that we can't overcome is because Apple has some very stringent licensing, and the SDK and the developer tools are not things that we can ship or integrate in any way. And so okay, there's two issues. That is the first one, which means that if you want to compile an Apple macOS app, you need to download the stuff from their website, install it, tell the compiler where it is, and then it will work as a cross compiler. The second challenge for iOS is that they have there's a mandatory requirement that iOS apps are built on Apple Macintosh hardware. And although I know that technically Linux could be running on a Mac machine, let's face it, the chances are that if you have a Mac, you can run Mac OS to do your iOS builds. So it's not really a target that makes sense to figure out how to support outside of, within the licensing restrictions.
Are you talking about, is that just a terms and conditions thing, or is that one of the tools that's restricted to be running on a Mac? You're not talking about just running Xcode, I suppose. You're talking about something different to that?
Yeah, I mean, you're right. It's not Xcode. It's the tools under the hood. It is terms and conditions. Anybody that manages to get the tools working on a Linux system and compile an iOS app, they will have violated the terms and conditions. And Apple has a nasty habit of deactivating developer accounts for people who do that, and for anybody who facilitates it, which is rather unfortunate. Now, that said, we definitely, continuous integration is really important. And we want to make sure that every platform can support every other platform. And so outside of those licensing restrictions, it should be possible. And Linux is actually the best platform for coding for everything else. It's just got so many tools available. It's just the Apple stuff under licensing that's a problem, which means that, Mac OS is kind of required as part of the process. However, because you don't need, or in an ideal world, you're not going to need any iOS specific code or any Mac code for that matter. A CI product that allowed you to say, here's my stuff, build it for me, could solve the licensing challenges for you. And I hope I'm not giving away too much to say it's an area that I'm exploring, and hope to have a much more comprehensive answer on how to do it easily in the future.
Cool. Looking forward to that. Is that part of Fyne Labs, is it?
Exactly.
Or is that going to be part of the, it is, okay. Thank you.
Yeah, I mean, we'll see how much of it we can share on a community level, and we're making sure that, as the toolkit and everything that's required to build your app is free and open source and permissively licensed. But some things, either through infrastructure or through other requirements, are going to be additional elements through some, yeah. Well, I mean, you get the idea, business product alongside a free toolkit is not unfamiliar, but we want to make sure there's no licensing restrictions on the toolkits and the widgets and the basic functionality. In fact, the enhanced functionality as well. We want to make it all free as much as possible.
Does that mean that you're going to be making, let's say, commercial only components or widgets